This video is intended to take you through the whole sequence of activities with the geometric constraints, and it's intended for students that miss some or all of the in-class practice, or if you have to share a computer with somebody and so you don't necessarily get to see and hear everything at the time that you want to see and hear it. Feel free to count how many times I say or in the video if that helps you pay closer attention, whatever works. I am doing this from a notebook with my own notes in it, so there's a chance that it'll get a little bit bumpy at time, and there's quite a few things that we have to do and that we have to look at and talk about. So please make sure that you're watching at least all or part of like the video that you need to watch, and you're not just rushing through it. There's a lot on here with geometric constraints. So I'm going to start by opening up a new design. And this particular one, the activity asks you to do it on the XZ plane, I believe. So the XZ plane, if you look over here at the right, is the blue and the green. Normally we use our blue and the red. Honestly, I do know colors. So we're going to pick this plane. Normally, I would have you pick the XY plane, and I think it says to use the XZ plane, so that's what we'll use. There you go. Okay, and you can tell up here if you look at our view cube. So the first part of this is to create a very general looking shape and to note the automatic constraints and remove all of them except what are called coincident constraints, and then pretty much practice with dragging the lines and the points around. So we're going to choose our line tool and do something like this. So I'm going to plunk down a line and we're going to draw it this way and then go kind of up at a diagonal and over this way and then down. And I got it going this way and then over this way and then close it up. Okay, so it looks something like that. And what we want to note are the constraints. So the constraints are these symbols that are popping up, okay? So this is a parallel constraint, and it was automatically applied to the figure. I did not actively try to make these lines parallel. In fact, I was trying not to make them parallel. But Fusion ascertained that, oh, it looks like she's trying to draw some parallel lines. So she, sorry, I can't just, yeah, you know what, it doesn't matter. So Fusion automatically put these constraints on here. You'll notice that there's a perpendicular symbol here for those of you that haven't taken geometry yet. That is a perpendicular symbol. It looks like a T. It looks like the little right angle. And if you look, they come in pairs. And so this line here is perpendicular to this one. If you were to continue drawing it out, okay, you would continue drawing it out and you could see that they were perpendicular to each other. And then there's a constraint down here. This is a horizontal constraint. And so it looked like I was drawing the line horizontally. And so Fusion automatically applied some constraints. Now, when we play around with this, we should be able to drag certain segments around. And so what the activity asks you to do is to drag certain segments around. So I'm able to drag this segment up and down. I can drag this out. Now notice that when I drag this out, it didn't pull it down, even though if you look at the arrow on my mouse, I'm clearly pulling it down. And the reason it's not pulling it down is because this segment here is constrained to be horizontal. If I pick this segment, I can drag it out, but I can't drag it so that it's not parallel to this one. Let's see what else. Move this down. Okay, I can move this over. And then if you start playing around, you can pick some of the points, okay? And so I can move this around, but notice that even as I move it, I can't make those two lines that are parallel not parallel. Okay, I can make them skinny. They're still going to be parallel. Even if I do this, they're still parallel to each other. You just can't see it as easily because they're not running next to each other. And I can pick like this over here, and notice I can mess around with the angle on that. My mouse is kind of on the wire. Okay, I can even drag it in and make it what's called concave. But this point here, I can drag it up and down, but I cannot drag it in a way that makes that line not horizontal. Now we can actually go and edit those constraints. So I'm going to select the sketch and select edit sketch. And if you want to remove a particular constraint, you highlight it. That's a left click so that it's bold, and then right click and you can just delete the constraint. So now that particular constraint is no longer on there. And so now if I pull this, notice I can pull that bottom line so that it is no longer constrained to be horizontal. So this first part of the activity is really just to draw a shape and then explore those constraints. Like take a look at the constraints that Fusion automatically puts on it. If I go back and edit the sketch again, I can go ahead and remove that. Notice that when I clicked on it, I did a left click and it highlighted both of the parallel constraints, and then we'll delete that constraint. And let's go ahead and delete this one as well. So we've now deleted all of those constraints. So now when I pull that, notice that those two lines don't have to be parallel anymore or perpendicular. So this sketch is not constrained at all. We can shrink the length of it. And again, the point of this part of the activity was simply to generate a sketch and then explore how the constraints work. Then the BLTW gosh, like their activity says, what does it tell them you to do? Like save this or something and extrude it, and then they never come back to it. So don't save it. Just play around with it. And make sure that you do this. You're not just watching this demonstration. Actually open up Fusion, create a sketch yourself, notice those constraints that happen to be on it, and get a little experience with dragging the sides and the points around to see how the different shapes behave. So the next thing we're going to do is, I'll like close that. No, I don't care about saving it. Is we're going to create another sketch, and we'll keep it on the XZ plane because I don't remember what they wanted. But there's a shape in the activity, and pretty much it does say use millimeters. So let me go change my document settings to millimeters just for this one. We're not going to change the default to millimeters, but just for this particular sketch. And the way the PLTW instructions are written, it says select any automatic constraints that seem appropriate. So I'm going to go ahead and start this. So we have a horizontal line up, in, and then so forth. And that looks good. Oh, I got a little corner on there. And what they wanted you to do here was, again, like observe the particular constraints. So let's take a look at what we've got here. This applied an automatic horizontal constraint. We have a parallel constraint here. If I select it, oh, shoot, I still have my line tool on. Undo. Okay, good. Okay. Now, if I select the constraint there, it'll tell me what it's tied to. So this segment here is constrained to be parallel to this one up here. If I select this constraint, well, no, sorry, I have a cat like tail there we go. And that one is selected to be parallel to this, which if you study geometry, you should know if this line is parallel to this line and this line is parallel to this one, then these two lines have to be parallel to each other. That's the transitive property, and it does apply to things being parallel. And then we have a whole bunch of perpendicular constraints. Okay, and I can click and drag and move this around. Notice that there's a perpendicular constraint applied there. So no matter how I'm kind of moving my mouse around and do some figure eights, it's holding that angle right there to be perpendicular. Okay. And then it says just drag the lines around to observe how they behave and then discard. Okay. Now we're pretty much going to draw the same thing, except this time they take you through it step by step. Oh, wait a minute. Nope, I want that. There we go. I did not want to start a new sketch on my cylinder there. So they take you through it step by step. The first step, and I copied this off of the PLTW site. So the first step says, oh, and we want to change those document settings to millimeters. There we go. So the first line, it says place a line on the x-axis, allow a horizontal constraint. So we're going to really work through this much, much slower, paying attention to each segment as we're putting it on into the sketch there and noticing what Fusion is wanting to do. So I'm going to go ahead and draw this on. Now notice in the blue there, and I can't make my mouse hover over it because my mouse is in the process of dragging the line, but notice that there is that blue symbol that's telling you, Fusion telling you, hey, I'm going to put a horizontal constraint on that. Okay, so there's the first one, and we have that horizontal constraint. Now we have a new line that should be perpendicular to the second. And if I draw it going straight up, notice it does say over there 90 degrees. And if you look down in the corner down here, okay, there's a right angle symbol, and that's telling you that Fusion is going to make that perpendicular unless I drag it over here or over here, and it's clearly not supposed to. But if it looks like I'm trying to make something to be a right angle, Fusion is going to give me that little shortcut and make it a right angle. The third line needs to be perpendicular to the second line, and then again, notice that perpendicular constraint. Now what that's going to do for those of you that have studied geometry is it's going to make this third line parallel to the first line. Okay, because if two right angles add up to 100, you know what, just we'll let your geometry teacher tackle that. Okay, so we're going to make that one perpendicular to the second line. Next one is add a diagonal fourth line. So we're just going to come up on a diagonal here, and it's telling me what the angle is and what the length of the segment is. And generally we don't care about that because we know we're going to dimension it. You know, if I really wanted it to be exactly 38 millimeters, good luck with that. Yeah, good luck with that. So we know that we can do a dimension on it later. So we're going to go up at a 90 degree or at a diagonal. And then the fifth line, we want it to be perpendicular to the third line, okay? And the third line is this line right here. And so we want Fusion to put a perpendicular constraint. So if you look up here and then like look right down here in this area, as I'm doing that, see that little perpendicular symbol is popping up. And so it's telling you that even though you can't see that third line being extended, these two lines are actually perpendicular. No, cat, go. Where did my mouse go? Okay. Should have perpendicular. Okay, the sixth line. They say in the PLTW curriculum, intentionally do it at a diagonal, okay, to stop. If you could do this, let me see if I can zoom out a little bit. All right. There we go. If you do this, Fusion is going to automatically make it horizontal. So it says do it at some kind of angle. Now notice even as I drop it down at these angles, these dotted lines appear, and Fusion is just so good like that. So if you wanted this diagonal to come down just to the midpoint of that line, it actually tells you when you've hit that midpoint. If you want to go down to the base of that line, to where the diagonal line stopped, okay, it would tell you if you go down here, midpoints. So Fusion very much anticipates a lot of symmetry and predictability in your design. Here we're trying to get it to avoid that, so I'm going to avoid anything that looks like Fusion is helping me. Okay, so we're just going to kind of come down at an angle and place the point there. So that was the sixth line. Let's see. Flip it over my notebook. Then it says complete the sketch. So the seventh line, we're going to force it to be parallel to the fifth. And so the fifth line is this line over here. And as I'm dragging it down, notice those little parallel icons that are popping up in the blue, and that's telling me, hey, I'm going to make that line parallel to the line over there on the left, and we're okay with that. The 8th line, we want it to be perpendicular to the 4th line, which is the diagonal. So this might be a little bit tricky. No, it's got it parallel. Aha, oh, there it is. Okay, just there. There's my 4th line over there. And we wanted that, let me make sure, 8th line perpendicular to the 4th. So we have a constraint popping up there. I just had to move it around enough so I could see it. So hopefully you're paying attention. Pause the video if you need to, so you can see that. So there's my diagonal. The 9th line we want to have parallel to the 3rd line, which I think it is, but it's not putting that constraint on it. What is it doing? It's making it perpendicular to the 5th line, which is the same as making it parallel to the 3rd line. So I guess that's okay. I don't think we can force it to do anything different there. And the 10th line, we're just going to connect this with the point to start with. So there we go. That's a thing of beauty. So just as a recap, this is line number 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 just brings us back to the starting point. And when you're doing this, you will have some kind of different shape, even though we're like really paying attention to those constraints as we're designing it. Yours is going to have some kind of like slightly different shape because we haven't dimensioned anything. So we like all of these dimensions are up for grabs. So now we're going to add some what are called manual constraints. So you don't have to rely on Fusion to decide for you whether things should be perpendicular or parallel and so forth. You can add constraints to force a design to do what you want it to do. So there's a couple things we're going to look through. The first one are lines 2 and 10 parallel. Well, this is line 2 over here, and this is line 10, and I think it's pretty safe to say they are not parallel because line 10 is at this weird angle. And so if you come up here to this panel, there's all these different constraints. So I'm going to go through them briefly. Okay, that symbol there is your horizontal and vertical. Inventor had 2 separate constraints for that. Fusion blends them into one of each, assuming that the line is going to be pretty close to what you want it. So a vertical line, like if you want it to be vertical, that it came out mostly vertical in your design and so forth. I don't know how much I really like that because sometimes our designs really go haywire, but that's your vertical and horizontal. This is coincident. And as you know, true Fusion fashion, the little blurb pops up. It constrains the position of 2 points or a point and a line or curve together. And so basically coincident, co means together. You're putting things at the same point. That's usually how I use it. So you can constrain 2 points to be like on top, like these 2 points are 2 different points, but I actually want them in the same spot. So what else do they say there? This could be a point constrained along a line or 2 points constrained to each other or a point constrained along a curve. So you want a point, but the point can just move along a line. This one is a tangent constraint. Those of you that have taken geometry will understand what that looks like. It constrains a curve and another object so that they touch at a single point but never cross each other. And I'll make sure that in the lesson part, I explain like what tangent means to those of you that haven't studied it. Probably that's everybody in algebra or geometry. You do study tangent curves and lines and stuff in geometry, but not until much later in the course. So you probably haven't seen that yet. Equal constraints constrains 2 things to be the same size, okay? So that they're identical. So if you have 2 things and you want them to be the same length, 2 lines, you want them to be the same lengths, but you haven't dimensioned them. You just know these have to be the same. You can use that. Next one is a parallel constraint. Forces 2 things to be parallel. That's the first one we're going to use. This is a perpendicular constraint. Okay. Fix and unfix, that fixes a particular point. So you might want to say, I think we actually have to do that. I think it says, yeah, fix the midpoint to the origin. It's actually the last thing that we do. So we're going to use that. And this is a midpoint constraint. So it constrains our point or object to the midpoint. So maybe you're going to mess around with the length. So you don't want to dimension it. You want to be free to change the length, but you want a particular point or object to stay at the midpoint. And of course, we have a drop-down menu. We have all of that. We also have concentric. Okay, constrains 2 or more arcs, circles, or ellipses to the same center. Think of like your bullseye. They have a nice little graphic there. Collinear means on the same line. Okay, so it constrains 2 things so that they're going to be on the same line together. Not necessarily like on top of each other, but just along the same line. So if you think to your algebra and your geometry definitions of lines, lines go on forever. And so you might have like 2 line segments and you want them to be on the same line, but not necessarily on top of each other. And then we have a symmetric, constrains 2 or more objects, so they are symmetrical. And that allows you to only change half of the object instead of the whole thing. And you just know that they will change, the other side of it will change together with it. And then curvature constrains 2 or more objects to create a smooth, continuous curvature between them. G2 continuity. Not sure I've ever used that one, but those are your constraints. So those are your things that allow you to control it. So let's start applying them. First one is our 2 and 10 parallel. So that's this segment over here on the left and this one on the right, and they are clearly not parallel. So to force them to be parallel, I'll click my parallel constraint. I'll click the first line and the second one, and notice what happened. That was like awesome. Okay, what it did was, because that line 10 wasn't constrained in any particular way, is that okay, we'll make line 10 and we'll force it to be parallel to line 2. And you'll notice the little parallel constraint icon popped up there. Next one is our lines 6. Oh, is 6 parallel to the x-axis? So 6 is this one. And we intentionally made that on an angle. So that one was intentionally designed. But let's say we actually do want it to be parallel to the x-axis. So we can click our parallel constraint and we can click that. That is already horizontal. We know that because it's got the horizontal constraint on it. And boom, we have made it be parallel. Next one is 5 and 7 should be the same length. So this is 5 and this is 7. And I can tell they're not the same length because this one extends below that line right there. You can just see, and this one is a little bit short. Okay. And so that would be an equal constraint. And it doesn't tell us which one we have to click first. So I'm just going to go ahead and click this one and then this one. And what you'll notice is that like whichever the first one is that you click, it'll change the second one to match the first one. So if I did that this way, okay, so I click my equal constraint and I click this one first, it shortened up line 5. Okay, to make it the same line as line 6. So sometimes that matters. Like in this case, it doesn't matter. You just want them to be equal. But sometimes it does matter. Sometimes you have one object exactly the way you want it, and you want to make sure you click that one first so that it's going to change the second one to match the first one. So you just want to be aware of that. And then it says lines 3 and 9 should align, and they don't. It kind of rhymes. 3 and 9 should align. So this is line 3 and this is line 9, and they definitely don't align with each other. They're way off. And so that's going to be our collinear constraint. We want this line, if we were to extend it indefinitely, to line up with this one. So we want them lined up. That's going to be a collinear constraint. And again, it doesn't tell us which one we have to go make match up. So I'm going to go ahead and click line 3 and then line 9. And notice what it did was it bumped line 9 down to line 3's height down here. If I had clicked them the other way, it would have brought line 3 up to line 9's height. Okay. And you do want to be mindful of that. Also, because sometimes when you put a constraint on something, it will completely jack up your whole drawing. So if it does that, what you might want to do is click undo and then click them in the other order. Okay, and it might do what like in your head you were picturing them doing. All right, and now like if we were to click on this and oh, okay, if we were to click on this and move it up and down, notice that lines 3 and line 9 move together because we align them to be collinear. And move them up and down together, in which we just did. Now we'll explore adding a construction line. So a construction line is a line that isn't actually part of your drawing, but is used to like do part of your design. Like but it's not actually part of the line. Think of it as like, for those of you that have graphed parabolas, we often put in the axis of symmetry into a parabola, and we do that so that we can see the symmetry and we can leverage the symmetry to make the parabola easier to graph. But the axis of symmetry isn't actually part of the parabola, and so you do it with this dashed line. So over here, you'll notice we have a line type, okay? And we have construction line. And I have like such an issue with this because I'll click it and then I'll forget to unclick it. So when you're done making your construction line, make sure you unclick it. So I'm going to click this and I'll come over and click the line tool. And what we're going to try to do is draw a line through the midpoints of 1 and 6. So you're like, well, how do I know where the midpoint is? Fusion is awesome. As I'm tracing my mouse along the line, you'll notice that that little triangle pops up. That lets you know you're at your midpoint. So I'm going to get my midpoint, click, and notice that the line is dashed. And then what I want to find is the midpoint of the bottom line here. So I got to kind of drag it along the bottom line, and there it is. And that is not what I wanted to do. Hang on. Fantastic. I thought I had clicked construction, but maybe I didn't. Let's try it again. There we go. That's what we wanted. Okay. And now make sure that you unclick it. I think we're going to have to click it again. Sorry about that. A little bit of an issue there. And you can see there's a little icon right there that lets you know that you were at the midpoint. Okay. It just lets you know that this line is connecting to midpoints. So again, a lot of information in this video with the symbols and how they work and how you would read what all these symbols are, especially if you haven't taken geometry or you're only in the second quarter of geometry. So a lot of this stuff you might not have encountered quite yet. Okay, so what are we doing? Note the midpoint symbol. If the line isn't vertical, add a vertical constraint. So horizontal, vertical in our constraint menu, and then we'll click that. And again, Fusion does it. Like if we had wanted that to be horizontal, we would have an issue. But Fusion is kind of assuming that, hey, it was closer to vertical than it was horizontal, so we're going to default to that. Okay, so we have a vertical constraint on that. And then it says fix the midpoint of line 1 to the origin. So here's the origin, and you can tell this whole thing is not centered. So if I want to center it, I would like to take the midpoint here and fix it to the origin. So let's go ahead and we'll click the midpoint and we'll click the origin, and it did not do anything. It did not do anything. Okay. Escape out. We'll do it the other way. Select objects to constrain. I am. Do they want me to select? Well, did I like unfix it? Okay, sorry about that. I had to pause the video for a second. There were a couple of issues. One, I had accidentally turned this line over here into a construction line, which I did not intend to do, which opened up my figure, and I just didn't notice that like I had an open figure there because I had clicked on the line and then click construction. And I think what we're going to do first is we're going to use the coincident constraint and then take our midpoint and failed to resolve. There's a dimensioning error. Let me try that the other way around. Okay, what that means, and I'll pause the video again to see if I can figure it out. What it's doing is it's saying it's not allowing us to make these 2 points coincident because it is violating some other kind of constraint that we have on here. So there's something else that basically there's some other constraint. And I actually have a note in here that says you might need to remove an automatic constraint in order to do this. So apparently that's me, that there's some other constraint on here that's stopping the whole figure from sliding. So I need to figure out what that is. I'm going to pause the video while I kind of try to troubleshoot that. And then once I figure it out, I'll unpause it, hopefully successfully. Okay, so you can see I managed to do it, and I promise you I didn't redo the whole design or anything. I'll kind of see if I can undo. So there's where it was. And then I applied the coincident constraint. What I had to do is I removed a perpendicular constraint from over here. And I don't know why that worked, but it did. So now when I click the origin and then I click that, it was able to move the midpoint of the figure over. And I honestly don't know. It was a constraint over here in this corner that I removed, and then that allowed the whole thing to move. Not 100% sure why. So if you're doing this on your own, try that. Try just deleting a constraint over there in that corner. And I'm not sure I remember which one it was. I could probably click back through here and see which one it was. Yeah, okay, it was a perpendicular constraint. And then you can tell I was kind of moving around it. Okay, so there's the perpendicular constraint. I could try putting that line back. So there's that midpoint line. And then, so now that perpendicular constraint is back. Oh, now it moved. I gonna chalk that one up to don't know. Just don't know. You can imagine my face right now. So we removed a constraint and moved it back. Okay, moving on. What on earth is next? So now we're going to put a hole in this. We're going to end up extruding this with a hole. And the requirements for the hole is the center of the hole has to align with this point here. So it's going to be right in this area. And it has to be tangent to the line going through this midpoint. So we have definitely a geometry hodgepodge. Now I don't actually want a line there, so I'm going to use my construction line. So my construction tool is back on. I'm going to hover over here until I see that midpoint icon, and I'm just going to draw the line in, and notice that we've got that automatic constraint going on right there, and I actually do want it, and there's that midline. It's not a line through the midpoint. So I'm going to put my circle. Now this is what I forget to do. I don't want the construction feature back on, still on. So we're going to turn that off so that when I get my, oh yeah, we want the construction off. I forget to do that all the time. And I'm going to draw the hole about where I think it should be. Okay. Something like that. That's about right. Okay, obviously not quite, but we'll get there. And I want that hole, I want some constraints on it. First of all, I want it lined up with this point right there. So here we're going to put a vertical constraint on this, and we'll click this point first and then the center, and notice what it did. It put this like vertical constraint on it so that the center of the circle is lined up right under that point. So what that means is that if I move this around at all, okay, notice that the circle goes with it. Okay, and I should be able to move the circle. I should be able to, it should just be a vertical constraint. There we go. Yeah, I should be able to, yeah, if I move the circle, I'm moving the point with it. Okay. So we've got that. Now the other thing we want it to do is we want the circle to be tangent to this line. So that's going to be a tangent constraint. And I don't think it matters what we pick first. There we go. And you see the tangent constraint. Now, a tangent line, for those of you that don't know, means it just intersects the circle at one point. So pretty much it just kind of touches the edge of the circle. It doesn't intersect the circle like through the circle at all. And I think that was all we need. Oh, we need to mirror it. So the last kind of constraint we're going to play around with is the mirror constraint or symmetry. And we're going to mirror that circle over to the other side. And so we'll pick this kind of constraint and, oh, did I not pick it? Symmetry. Oh, it's like, wait, we're still in that construction line. Maybe that was the problem. Symmetry. Oh, grumble, grumble, grumble. Oh, no, wait. I'm picturing the mirror tool because I'm trying to do it like, okay. Now I got to stop and think. I would do this with the mirror tool, not with the symmetry constraint. I'm trying to think. Okay, if we do it with the symmetry constraint, we would like draw the circle over here. And then I think we could do it where we'd pick the two objects and then the line of symmetry. There we go. Okay, and now we've got it. I don't think I would do it that way. But I guess I think I would do it using the mirror and then select the circle and then select the mirror line. But okay, using the symmetry constraint, I just wouldn't have done it that way. We draw the circle and then we click the constraint and say basically make sure that these are the same. So if I drag this circle and make it bigger, it should make the other circle bigger with it, because now we got that symmetry going on. All right, last little piece of this are the dimensional constraints. And so all of this, the first bajillion minutes of it, like 37 minutes of this video, are geometric constraints, exploring the constraints, designing with those constraints in mind. And notice that we haven't actually put a specific dimension on any of this. And it's really important that this is a way that you learn how to design, because sometimes you might not know specific dimensions, and you want to make sure that if you need to go back and change your design, which we do, that you pretty much dimension as little as possible and the rest of it will take care of itself. So you really need to ask yourself what's important. So let's go ahead, and these are the dimensions that they want us to add. They want this up top here to be 20 millimeters. And before I do this, if you apply a dimensional constraint and it jacks up your figure, okay, so it turns stuff inside out, upside down, and sideways, delete that dimension, like click undo and dimension something else first, okay, because sometimes the order that you dimension it is going to matter. And if you dimension the wrong thing first, you won't even see what you're trying to, yeah, well, hopefully it won't happen. So that needs to be 20. This here, and if you have trouble grabbing it, go ahead and zoom in. This is supposed to be 15. This is this one over here is also supposed to be 15. Don't bite me. Sorry, I have a cat who does actually bite. Okay, now we want the distance from the entire top to the entire bottom to be 45. So to dimension that, we click the top line, then we come down, click the bottom line, and we drag off to the side, and that's how we get that dimension there. Super jacked up. I don't know if I like that move. Hey, Pepper, you want to be a part of this lesson? This is an annoying delay. My students aren't going to appreciate it. You gonna come up on my lap? Just don't bite me, okay? So what I don't like about this is it's really, really distorted the shape of it. It might get fixed when I go and dimension the circles, but I'm not 100% sure. So this, they want the diameter to just be 5 millimeters. And then this is supposed to be 100. Clearly not what we're supposed to have. So so we got to go back and redo some of this. So go. Where did this start to go astray? I'm gonna do this. Oh, click my dimensioning tools. So I'm gonna try to troubleshoot this so that you guys can kind of see. I'm gonna make this the 100. No, I don't like that either. Let's do this. Make this the 5. Okay, I definitely like that better. So we've got that. The problem is, one, I don't like that. There we go. Move that out. Also gonna uncheck. What I just did over here was where it says show constraints. I just unchecked it because I felt like that was starting to clutter up like the figure here. So the problem is that when I make this smaller, this over here is not constrained in the same way. So it's symmetric. Okay. That's why I don't like that way of doing things. I am going to actually gonna see if I'm gonna do this a different way. Consider it a learning opportunity. I would like to delete that circle. Okay, I don't like how we did it. You guys got to see a symmetric sketch. Yay. And I'm gonna create that circle a different way. So what I did was I came over here to the create panel and I'm gonna do a mirror, and it's gonna prompt me to select the object that I want to mirror, which is the circle, and then the line over which I want to mirror it. And why? Wait a minute. That line stopped being vertical. Hold up. When did that happen? And why isn't it a construction line? Okay, that needed to be a construction line and also needs to be vertical, and it's clearly not. Okay. That is still not right though, but let's see what happens when we dimension this now. I don't like that either. Let's do grumble, grumble, grumble. Let's do this dimension. Put it over here. And that was supposed to be 45. And then this is supposed to be 100. I think it's going to get super distorted. Okay. Okay. I deleted another dimension. I think what I want to do, not sure this is going to work. I want to apply a symmetric constraint on these two pieces. Yeah, I like that a little bit better. Okay, that's not in the directions anywhere, but I think that helps. Yeah, like I think that's what we wanted. Okay, and so now let's make this the 100. There we go. Got it. Okay. So if you're watching from home, or I'm making you watch this and you're counting how many times I say in the video, then that was the missing constraint. So make sure you apply a symmetric constraint to these two pieces right there. That's not in their direction. Well, actually, at this point, there's a discussion in the PLTW curriculum about whether or not you believe that your object is what's called fully constrained. And so being fully constrained means that it does not get distorted in a way that you're not expecting. The problem, I think, in the curriculum is that they make you do this first, and then they ask you if it's fully constrained, which it's clearly not. And it means you can't get here until you fully constrain it. So that's what it means to be fully constrained. Actually, we just got a great view of what it means when something's not fully constrained. It means that when you start applying constraints or you start dimensioning things, that you're getting distortions in the object that you did not want to have. And so you have to go and constrain everything. And the problem is that we did not have these two diagonal pieces constrained. Okay, we didn't have them constrained. And so when I was changing the dimensions, it was messing around with these so that they weren't symmetrical. And what we needed in order to force the sketch to change the way I wanted it to change, I had to go back and constrain those. So hopefully when you're doing this, you'll get that faster and you won't take, how long are we up to? 1 million hours, 46. Just feels like I've been doing this. And I have to go to the symphony tonight. So I need to figure my life out between now and then. Okay, so there's your discussion on fully constrained sketches. And then there's a video to watch in PLTW, and I'll have you guys do that in class. But what they want you to do is predict how the object is going to change if you change the 100 millimeters to 125. And so I'll pause the video for a second and think okay, if I change that number to 125, what does it end up being? How is that going to change the sketch? And now we'll actually do it. Okay, notice what it changes and what it doesn't change. So the only place where it's got any kind of give is in these segments right here, because this is locked into place. Okay, and so when we change that, that's where it's got to give. If I had dimensioned these and then tried to change it, it would tell me this is over constrained your sketch. And some of you have gotten that warning when you've been designing stuff. It says this over constrains it. And now you know what that means. It means you're telling it to do contradictory things. Then in the next part says, what if you changed this vertical piece from 45 to 60 to 80? So you need to think about where you have give to make it taller. This is locked in at 15. This is also locked in at 15. These are the pieces that are not dimensioned. So if we're going to make it taller, the only way to make it taller is to increase the length of those. So let's see what happens. And you can see that is indeed what happened because that's the only place that it wasn't already constrained. If I make it 80, okay, and notice that definitely distorted it because in order to increase the length of that, it had to give somewhere else. And this is not dimensioned to a specific length. So that was flexible to be able to change. We'll make that back to 45. So now what they want you to do is change the overall height to 100 on your sketch. And I'm not going to do it because if I do it, somebody can take a screenshot of this video and submit it as their own instead of working through this whole hot mess of constraints. And I don't want that to be available for you. So you're going to do yours, change it to 100. Okay, have a great time with that. And then you're going to screenshot it, write your name all over your screenshot. Okay, don't obscure anything important. So make sure I can see all the stuff that I need to see on this, but you can do your name right across the middle there. Okay, so that there's no question about who's the person that did all of this awesome work in Fusion, learning about constraints, and then paste it, do a copy paste. And I think I'm going to open it up in Focus so you can upload it into Focus, or you can post it on Teams. Just make sure that you tag me in that post in Teams. So it will give me a Teams notification, and it also sends me an email, which is fantastic. Okay, so go ahead and change that. And that completes the lesson on constraints. Wow.